All right, so we are live right now. I hope I'm audible to all of you. Just let me know in the live chat. Am I audible to all of you? Okay, so welcome back. So I welcome all of you to this amazing platform of Tutee Learning. And today we're going to discuss about another important form of questions and properties regarding the straight lines, right? So today our class is going to be a bit intensive as well as for the person who are basically preparing for the JEE Mains and Advanced examination. Yet, those questions are very fundamentals, right? So we will look into the fundamental aspects of every questions and we'll try to see the basics formulation for those questions and we'll try to apply that in different types of formulation, right? So let us start with today's discussion on equation of straight lines, right? Now, before I start to discuss about the equation of straight line, I want to ask you this question very clearly is that I hope you have tried to solve for the homework problem, right? Now, please make sure that whatever homework problems I'm giving to you daily, please try to solve them, okay? Otherwise, you won't be actually getting the understanding of the chapter, right? The time you are basically attending the class and you are just taking up notes won't actually help you to understand the chapter unless and until you apply them to the questions, right? So it's very important to basically, along with the understanding of the notes and the class discussion, please also try to solve the problems that I'm giving to you as a homework, right? So whenever you are done with the theory part, you are done with the understanding of the formula, it is very important to also solve and practice some question and to see whether you are able to test your knowledge or not, right? So with that particular discussion, this was the question that I asked all of you to solve in our previous class. So I hope you have at least tried to solve this problem, right? I'm not saying that you will be able to solve it problem completely or not. I know that many of students can be able to solve this problem or won't be able to solve this problem. However, it's my responsibility to basically discuss this particular problem. So let me quickly discuss over it so that students who have tried to solve this problem but were unable to discuss or solve it completely would definitely get to know or learn something new in this problem, right? So what we'll do is that we'll try to use the concept of reflection, right? So in our physics, what we have learned in the concept of reflection, that we have seen that the incident ray and the reflected ray at the point of incidence, the angle of incidence and the angle of reflection, they are both going to be the same, right? So that was what we have learned, that this is theta I and this theta r, right? So at because of reflection, this theta I and theta r is equals to same. That is the law of reflections, right? So what is given over here, a ray of light sent along this particular line. Let us say this particular line, which is marked as 2x, sorry, which is marked by x minus 2y is equal to 3 and is sent along or upon reaching the line, this particular line is the mirror line. So let us say L2, that is given as 3x minus 2y is equal to 5, right? This is the mirror line, right? So let us call this as mirror. Okay, so upon reaching the mirror line, it gets reflected, right? So we have to find out the equation of the line containing the reflected line. So from the problem, it is very clear that if I am able to find out the slope of the first line or the incident line, so let me call the slope of the incident line as mi, or okay, and the slope of the reflected line be mr. Okay, this is the slope of the reflected line. Okay, so if I am able to find out the first of all, what I am going to look out is that let me first of all find out a point lying on the reflected line, and the second thing that I am going to look out is the what is the slope of the reflected line, right? So for the point on the reflected line, it is very simple that if we find out this particular point of incidence, then that is going to be the point that is also lying on the reflected line, right? So how am I going to find that? So in order to find that particular point of incidence, let us call this point as some point A. So we have to solve for line L1 and line L2, right? So if you solve the line L1 and L2 for the point of intersection, we'll definitely get the our point of incidence, that is point A. So if you solve it by yourself, so it is very simple. If you just subtract L2 from L1, you will definitely get 2x is equals to 2. So x equals to 1 and then I will get y equals to, so if x equals to 1, y should be equals to minus of 1, right? That is the point of intersection, okay, or the point of incidence, right? Now another thing that what I'm going to do is that, now if this theta and theta are equal, then if I consider this particular angle as alpha, then this should be also be alpha, right? So what is this alpha denoting? This alpha denotes that the angle made by this line L2 with the L1, and similarly this alpha should also be the same, that is made by the line LR, that is made by the line LR with the line L2, right? So if I try to apply the concept of angle between the line to find out tan alpha, so tan alpha from here I'm going to get it as, so the slope of line L2 is 3 by 2 minus of the slope of line L1, that is going to be 1 by 2 divided by 1 plus 3 by 2 multiplied with 1 by 2, right? 3 by 2 multiplied with 1 by 2, right? And this if I calculate, I'm definitely going to get the tan alpha as 4 upon 7. So I'm going to get tan alpha to be coming out something as 4 upon 7, right? Now in the similar sense, if you try to apply the angle theorem over there, the tan alpha for the reflected line and the mirror line, so the tan alpha is going to be 3 by 2 minus m of r divided by 1 plus m of r into 3 by 2, right, and mod of it, and that should be equal to, 4 upon 7, right? And that should be equal to 4 upon 7. So if you solve this equation, so if you from here, if you solve this equation, you will definitely get the value of mr. You will definitely get the value of mr, right? So if you solve this equation over here, you will get to the value of mr, because it is a modulus put over here, so you will definitely get two values of mr's. Okay, so please try to find out the corresponding to values. So if you try to find out the corresponding values, you will see half is also coming up, and one more value will be coming up as 29 by 2. Now half cannot be the reflected line, because it is basically traveling along the mirror line. Oh sorry, it is traveling along the incident line, right? It is basically the incident line, right? Okay, so it is basically the incident line, which cannot be the reflected line, right? So therefore 22 by 2 should be the accepted slope solution, right? So from here I can obtain the equation of my reflected line as 29x minus 2y minus of 31 is equals to 0. So this is my equation of the reflected line. Okay, I hope this is clear to all of you. So in the similar manner, if you are clear with this question, and in order to how to find out the slope from the angle between the line concept, you can definitely try to solve problems not only on reflection. Maybe if you give a problem on refraction, maybe that also you will be easily able to solve it, right? So what I'm going to do is that I will definitely leave this particular problem for all of you, so that you can try it out. Okay, so that you can try this particular problem out, and maybe you can let me know the answer in the live chat or maybe in the comment section. Okay, so I'm attaching the problem over here. So the question says that a ray of light is sent along, uh, the equation is given, the ray of light is given along some particular equation, and it is said that it comes out of the opposite form. Yeah, so it says that, and it enters the opposite side after turning by 15° away from the line x plus y equals to 1. Find the equation of the line along which the reflected ray would travel. Okay, so what you understand is this question is that it is said that if I have a glass slab, let us say this is a question of refraction, right? This is a concept of refraction. So refraction happens because of changing speed of the light in two different media, right? So if it is said that a light is sent along this particular equation, okay, is sent along this particular line, so let us call this, let us say that it's from coming from some source P, and it is inciding at point Q on this different medium, right? And it is said that it is this particular equation along which the line comes from is given as 2x minus 3y is equal to 5, right? That is what is mentioned. And similarly, after refracting, it is mentioned over here, after refracting across the line x plus y equals to 1, so x plus y equals to 1 is this particular line of the slab, okay, or the medium difference, or the interface between the two mediums. Okay, so this is my first medium and this is my second medium, right? By now you must have already studied electromagnetics, and by that particular concept you have seen that the speed of the light in a given medium can be simply given as, so speed of the light in any medium is given as 1 upon, so if I write the simple formula, it is basically electric field intensity upon the magnetic field intensity. And if you solve this part out by the concept of electromagnetic induction waves, so you will come it as mu naught mu r epsilon r, right? So I hope you have all studied what is mu naught mu r, relative permeability and relative permittivity, right? So if you do that, you're easily going to get the speed of the light in any electromagnetic wave in a given medium. And this 1 upon mu r epsilon r is basically called as the refractive index. Okay, so 1 upon this is basically the speed of the light in the free space, which I'm representing by, so 1 upon mu naught and epsilon naught, and square root of that would definitely imply the speed of the light in, or speed of the electromagnetic wave in a free space or vacuum, right? And divided by the so let me write it as nu, okay, which is basically meaning the refractive index. Okay, so refractive index is a concept of, or the measure of how, or the ratio of this change in speed of the light in a given medium with respect to the free space. Okay, so that is called as a refractive index, right? So this is how we calculate the speed of the light, right? But this is bit of physics over here, right? Now, and it enters the opposite side, so this particular side also will have the same equation, because these are parallel slab or glass slab or rectangular slab, so obviously these are going to be parallel. So it is saying that it comes out, and it enters the opposite side after turning by 15-degree angle, right? So it was going like this particular, but because of refraction it will have turned by some particular angle, right? So it is mentioned in the problem that this particular angle is given as 15-degree. Okay, this particular angle is given as 15-degree. So you have to find out the line equation of the line along which the reflected ray would travel. Okay, so I hope this question is clear to all of you, right? So please try to solve this problem. I think you will be able to get the problem or solution of this problem very easily, right? So please try it once, and I don't think this is a difficult problem. Okay, if you just try it on your own, I think you will be able to get the solution by just applying the concept of what you have learned as in the angle between the straight lines. Okay, so please try to use or the concept of angle between the straight lines in form of slope, and then you try to solve this particular problem. Okay, so I leave this particular problem to you, so please solve this problem and let me know the whatever solution or answer you're getting in the live chat or maybe in the comments. Okay, so I hope for the answer from all of you. Okay, is this part clear to all of you? Is this part clear? Just let me know in the live chat, is this clear? Yes or no? Okay, just let me know in the live chat, is this part clear or not? Okay, so I hope this part is clear. So let us now discuss about another very important form of writing the equation of straight line, that is called as the parametric form, okay, or distance form. So distance form of line equation, okay, or distance form of line, or we call this as parametric form. Okay, parametric form. So this is called as the parametric form or distance form of line. Okay, so let us try to understand what this particular thing implies, right? So if we have any particular line, let us say this is my coordinate axis, and I know a given line, and I want to represent this particular line, let us say something like this, such that it makes an angle theta with the positive x-axis. Okay, and let us take any point on this particular line as point Q, and let us say this Q point is my known point. Okay, this is my known point on the line. Now I want to represent any point P, which is a parametric point, in terms of some parameter which is given in as distance of d from the point Q. So I want to find out a point P on the line which is variable point, and which is basically making a distance of D from the known point or my fixed point Q, right? So this Q point is my fixed point, right? So this Q point is my fixed point, and I want to find out the coordinates or the variable coordinate of that particular point which is making a distance of D from my known on the fixed point, right? So how am I going to do that? It is very simple. So for doing this, so for representing this, I'm going to use the help of trigonometry, right? So what I know over here is, let us say the line is making some angle theta with the positive x-axis, right? So this particular angle is also going to be theta, right? So what I'm going to do over here is that by constructing this right angle triangle, I can also find out this distances, right? So this particular distance along the x-axis is going to be x2 minus x1, and the distance of P from Q along the y-axis is going to come out as y2 minus y1. Okay, I hope this is clear. Okay, so once I know this particular distances in this right angle triangle, let us call this point as point O, or maybe let us say point N. Okay, so I know this particular right angle triangle, right? So in this triangle QNP, so in this right angle triangle QNP, if I try to find out what is my cosine of theta, so cosine of theta would be coming out as x2 minus x1 divided by this known distance d, right? So what I don't know, and this is not x2, should be x, right? So I don't know what is my x, right? So this is my x. So x minus x1 is equals to d times cosine theta. So I can write x1 as, so x I can write it as x1 plus d times of cosine of theta. So and similarly we can write y as y1 plus d times of sine of theta. So instead of taking cos, if you take sine, you will be able to get this particular form. Okay, so this implies that the parametric form or the unknown point on the line is basically replaced by only one particular thing, right? So if you know that d, that distance which is already known to me, that is a constant, this x1 y1 is known to me, it is a constant, and also theta is known to me, right? But let me take that, let us say it can be a variable theta as well, right? So let us say the line can be varied, but the distance is remaining the same, or the distance can be varied, the line is remaining the same. So either by varying theta or either by varying d, I can obtain multiple sets of x and y, right? So what I understand is that this d and the theta is kind of acting like a parameter. What do you mean by parameter? Parameter basically means that if you have a set of equation which is dependent on some particular thing, right? Let us say I have a simple function y is equal to f of x. So here what I explain by parameter is that, let us say I have some function y is equal to f of x, right? And let us say f of x is also a function of some parameter theta, and y is also a function of some parameter theta. Okay, so let us not write y is equal to f of x. I should write some function like f of x comma y is equal to some 0, right? Let us say some constant, right? So in this case my x and y are two variables which are again a function of one particular variable theta. So what I'm doing is that if I keep on varying this theta, I will definitely obtain some sets of x and y, and which will definitely generate my plot, right? So what I understand is that this theta is a parameter which is varied and to generate a different set of values. Similarly over here, this theta or maybe either d can be varied to obtain the different set of point on that particular line, right, to obtain the given point. So this is called as a parametric form of any line equation. So what I generally write is this particular thing as, so since my d is a parameter, so what I do is that I write the equation as x minus x1 upon cosine of theta is equals to y minus y1 upon sine of theta, and that is equals to plus or minus some distance, that is d, right? So this is also called as the parametric form of line equation, where d is the distance. And why did I write over here plus or minus d? Because the distance can be taken in the forward direction or maybe taken in the negative backward direction, right? So this way also the distance can occur. So here also I can have this p point as well, right? So if I have to mention that I want to take the point forward of q or backward of q, it will depend upon whether I take the plus or the minus sign. I hope this is clear to all of you. Is this part clear? Ritesh Bo, yes, great. So, okay, so let us now then try to see that how we will apply this particular thing in solution or solving some problems, right? So I hope this concept is clear. This concept is a very important concept. Please take a note of it, because in solving questions not only of straight lines, however, in some questions of circles also, we will see that how this type of parametric form is going to help us in order to understand the different difficult problems as well, right? So we can use this particular forms to solve any number of problems, right? So I hope this is clear to all of you. Just let me know in the live chat, is this clear or not? Okay, so that I can move with the question. Okay, so let us see how we use this particular concept to solve some interesting problem, right? So if you recall, now as similar to the problem of reflection in a plane, I can also give you a problem where the line is rotated by some particular angle, right? So in the questions where we will have the concept of rotation of a line, here the parametric form is going to play a very important role. So the question is shown over here. Okay, so we have a question which is relating the line joining 2 points is rotated about a point A in the anti-clockwise direction through an angle 15 degree. Find the equation of the line in the new position B. In the new position, if B goes to C in the new position, what will be the coordinate of point C? That is a simple problem, right? So you can easily solve this kinds of problem. So what you see over here is that the distance remains the same. So when you rotate, so let us say we have this line which is something like this. Let us say this is point B. So when you just rotate this particular line by 15 degree angle, the distance from the fixed point, let us say this is my fixed point P, the distance of this point C is the same, right? So here D is not a parameter, but indeed my parameter is this particular angle, right? So here my theta is 1 and here the theta is theta 2. So the theta is varied, okay? So the theta is my parameter over here. Okay, so that is what I actually mean to explain to you when I was describing the parametric form. So it may not be only the distance, it may be the theta also may be the parameter, right? Where the distance can be fixed. So please try to solve this problem. So first of all, the solution step is quite a simple step. What you can do is that first of all, try to find out the slope of the line. Let me formulate the problem. So the question is basically given as far as, so here it is said that this particular point is point A, right, which is coordinate is given as 2 comma 0. It is lying on the x-axis, right? So somewhere here I will have the origin, sorry, right? So here I will have the origin, and and then I have to, and this theta 2 minus theta 1 is given as some 15 degree angle, right? So this theta 2 minus theta 1 is given as some 15 degree angle, right? So now, so I have to just find it out the point C, right? I know the point A. What I can do is that I can solve this problem without using parameter form also, and maybe that would be a try to solve this problem in a simpler way just by the use of parameter, right? So what I can do is that I can write the parametric form of this any line as x minus 2 upon cosine of 60, because this theta 1 is going to be 45 degree and this 15 will make it 60, right? So I'm writing the equation of line AC, right? So x minus 2 by cosine of 60 is equals to, is going to be equals to y minus 0 by sine 60, right? And this will be the parametric form. This will be the parametric form for the equation of the line. So by this I can formulate the equation of the line, and the only thing that I have left to calculate is basically the distance, right? Is basically the distance. So how am I going to find the distance? The distance is very simple. So I can find out the distance of AB. That is going to be square root of just square root of 3 minus 2 whole square plus 1 minus 0, 1 minus 0 square, and that will turn out to be square root of 2, right? That will turn out to be square root of 2. So if I just equate it to square root of 2, then I'm easily going to get the coordinate of my point C. So if you try to do this problem in this following manner, you will see that the coordinate of C will turn out to be, the coordinate of point C will turn out to be just 2 plus 1 upon root 2, 1 upon root 2, comma, C root 6 by 2. Okay, root 6 by 2. So this is my coordinate of the unknown point C, which is basically having the same distance but is just rotated in 15-degree angle in the anti-clockwise direction. Okay, I hope this question is clear to all of you. I hope this question is clear. Is this part clear? Just let me know in the live chat, is this part clear or not? Okay, in case you have any question, any doubt, please let me know in the live chat so that I can definitely help you out with that particular problem. Okay, so please try to take the best use of this live classes so that and you can interact with me in order to understand your concepts better. Okay, I hope this is clear to all of you. Is this part clear? Just let me know in the live chat, is this part clear or not? Okay, so with this particular understanding, let's now proceed towards some more important formulation. So before I do that, I want to give you this particular problems as a homework problems. Okay, so I will have three problems as homework problems. So please try to solve these problems as homework. Okay, and let me know the solution in the comment section of this particular video, or maybe you can also let me know the answers in the tomorrow's class. Okay, so tomorrow again when you're going to meet, you can also let me know the answer for these questions. Okay, so please try to solve this problem. These problems are going to be pretty straightforward. Please try to solve this problem and let me know the solution you will obtain once after solving this question. Okay, maybe you are not able to solve any problem, don't worry, you can just let me know the question number or which problem you are not able to solve it so that I can directly solve it for all of you in the live class. Okay, so with this, let us move towards another important concept that is called as a congruency of three lines. Okay, concurrency of three lines, sorry. Okay, so what do we actually mean by concurrency of three lines? Okay, so what's the of three lines? So by now we have already finished understanding the concept of equation of lines, right? So by now formulate the equation of the line, you are in a position to easily formulate the equation of the line, right? However, concurrency of three lines actually means that if I have three lines, if I have line 1, line 2 and line 3 are passing to the same point. Okay, if I have just two lines, it is always going to have a point of intersection if they are meeting each other, right? So but the three lines may not be have a common point of intersection, right? So in order to have this common point of intersection, which is called as a concurrency of three lines, the concept is very simple, right? So what we need to follow, if the three lines are concurrent, the point of intersection of the two lines will definitely going to lie on the third line, right? That is my simple idea. So if I take three line equations, so by now we have seen that the line equation can be given as ax plus by plus c is equal to 0. So I'm writing the three equation as a1x y plus c1 equal to 0. The line a2x plus b2y plus c2 is equal to 0 is a line 2. And similarly, I'm writing the equation of the line 3 as a3x plus b3y plus c3 is equal to 0. So that is my three equations of the line. Okay, those are my three equations of the line, right? So if I find out the point of intersection of line 1 and line 2, and if this particular point of intersection lies on the line 3, then they will be concurrent or concurrent lines, right? So if you just try to find out the point of intersection of this first equation and the second equation and try to put it over here, you will finally obtain a relation which is the determinant of this particular values. You will see that this particular thing will turn out to be the determinant of this should be equal to 0. Now please note that in this concurrency result, all these C points are not on the right hand side, it is on the left hand side. So please, first of all, whenever you are given any equation of line, first of all, please try to make all the C points lying on the left hand side. Okay, so please make all the points on the left hand side and then you try to apply this particular determinant concept. Okay, so I hope this is clear to all of you. Is this part clear? Now we can also solve this problem by utilizing the concept of family of lines, right? So which I am going to definitely discuss in our upcoming formulations. Okay, so I hope this is clear to all of you. I hope this formulation is clear to all of you. So with this, I would like to conclude the session with some problems. Okay, so maybe you try to solve these problems and let me know the solution. So these kinds of problems are very standard problem where you don't actually need to find out the point distance formula, or just by finding out the 2 points when distance formula applying to get to the distance, whether we can also use parametric form of line to also find out my given distance. So if you take out from this particular problem is that what you will see that find out the distance of a point 1 comma 3. So let us say we have a point 1 comma 3 over here. So if you read for the question, we have to find the distance from point 1 comma 3 from a particular line. Okay, so let us say this is my line whose equation is given as 2x minus 3y plus 9 is equal to 0. That is my equation of the line, right? And we have to find out the distance of this particular line which is measured along some particular line, and this is my line 2 that is given as x minus y is equal to 0. So in order to solve this problem, the easiest way and the safest way to solve this problem is just by finding out the equation of this line L2 in the parametric form, right? So how am I going to do that? So if you try to find out the slope of this line L2, this is L2, I should write it properly. So if I try to find out the slope of the line L2, I will see the slope will turn out to be 45 degree. Okay, it will turn out to be just 45 degree. Okay, so from this I can formulate the parametric form of this line by x minus 1 upon cosine of 45, that is going to be 1 upon root 2 is equals to y minus 3 upon 1 upon root 2, and that will be equal to some distance d, right? So I have to find out this particular distance, right? Okay, so this is any point on the line L2, right, in the parametric form. Okay, so this is any equation of parametric form of the line L2. Now any point on this line can be given as x is equals to 1 plus d upon d upon root 2, and the y point can be given as 3 plus d upon root 2. Okay, 3 plus d upon root 2. Now if I just solve by putting this particular coordinate point in this line equation L, and then I can obtain my value of this parameter d. So if you try to do that, so please try to solve it by yourself, and you will see that the value of d should come out as 2 root 2, right? So this will give you the distance of this particular point, or the fixed point 1 comma 3 from the point which is meeting the line L along the line L2. Okay, so this particular distance is going to be the final answer. So I hope this question is clear, and I hope I was able to give you a understanding that whenever you have to find out distance, or maybe the line is rotated, or maybe the concept of two lines having the same distance, so that where the theta is varied or where the theta is kept same, thus the point is having some distance from the line. In order to solve this problem easily, we can take the help of the parametric form. So in certain problems, even if you try to solve this problem by just by formulating the finding out this point on the line L2 and L1 by finding on the intersection point, you might have to do some more further steps, right? And then you have to find a distance formula, right? Rather, without using that particular thing, just by using the parametric form, you can easily solve this problem. Okay, so please try to take the help of parametric form as much as possible and wherever it is applicable, right? So this will actually help you in order to understand the concept in a better way, right? So in the next class, we're going to discuss about the upcoming topics, that is going to be the properties on the distances of the line of a point and the line, and following that we are going to discuss about how to find out the distance between two parallel lines, right? So those are the important concepts that we need to understand, that is a point and a line and two lines, right? And once we are done with that, we are definitely going to move into the concept of equation of angle bisectors, and following that we are definitely going to enter into our main concept or generalized concept, that is called as the family of straight lines, and following that we are going to go into deep into the conic section, starting with the pair of straight lines. I hope this discussion is clear to all of you, and I hope that I was able to give you a better understanding of this entire chapter. So with this, I thank all of you for this for your attention, and I hope to see you soon in the other live classes. Okay, and with that, I wish you can also solve this homework problem and let me know the solutions or maybe the answer in the comment section, or maybe in the tomorrow's live class. Okay, so see you again in tomorrow.